theorem and Norton's theorem. So are you able to see the whiteboard now?
Yes.
Yes, sir.
Hmm? Okay. So network theorems. So we have the network theorems. Network theorems. So first one is that superposition theorem. Anybody knows what is the statement of superposition theorem? The statement of superposition theorem. Statement of superposition theorem. What is the superposition theorem?
In a linear bilateral network, the current flowing through any element is equals to the algebraic sum of the individual current flowing through.
Yeah, it is a simple theorem in a linear bilateral network, right? The current flowing through any element, the current flowing through any element is equal to the algebraic sum of individual currents when sources are acting alone. When it is acting alone, so here superposition theorem statement, I am not written again statement. So directly I am considering the circuit. Here I am considering one circuit. This is a simple circuit. Here it is V1 and here it is V2. These are the resistor R1, R2, R3. R1, R2, R3. Right? So now when V1, V2, both sources are on, both sources are acting, it means both sources are on. Whatever the current flowing through R1, here I am assuming it is I1. Whatever the current flowing through R2, that is I2, and whatever the current flowing through R3, that is I3. So I1, I2, I3 are the currents flowing through R1, R2, R3. When both sources V1 and V2 both are acting, right? So now next what I am doing, according to superposition theorem, according to superposition theorem, consider at a time one source only. If the network has the 1,000 active elements, mean 1,000 sources are there, either it is voltage source or either it is current source. If you have the 1,000 sources, number of sources are there, consider at a time one source only. So here, so when I am considering one source, the remaining source should be replaced. So replaced. So remaining source should be replaced, and if that source is voltage source, make it short circuit. If it is current source, make it open circuit. So here it is voltage source. That's why here what I am doing, it is short circuit. Yeah. So here when I am considering V1, the resistor R1, R2, R3 as usual, right? Then current flowing through R1, current flowing through R1. Here I'm considering source 1. That's why here just I'm denoted with I1 dash. Here it is current flowing I2 dash. Here it is I3 dash. Right? This is, so we have to calculate I1 dash, I2 dash as well as I3 dash. These are the I1 dash, I2 dash, I3 dash. These are the currents when I am considering the source 1. Then next one. So consider another source. Consider another source. What is that another source here? V2. So when I am considering another source here, V2 source I am considering. Then V1 ఏం చేయాలి? What we have to do V1?
Short circuit.
Short circuit.
Replace it and make it short circuit. Again, as usual, R1, R2, R3. Then whatever the current flowing through R2, that is I2 double dash. I'm calling it is some notation double dash. Why I'm calling with I2 double dash? Because of second source. Whatever the current flowing here, that is I1 double dash. Whatever the current flowing here, I3 double dash. So here, when both sources are on, yeah. So when sources, when V1 means when both sources is on, both sources is on, the current flowing through R1, that is I1. Then when V1, only V1 is on, the current flowing through R1, that is I1 dash, it is when the statement is very simple. In a linear bilateral network, the current flowing through any element is equal to the algebraic sum of individual current when sources are acting alone. When V1, V2 both are on, the current flowing through R1, that is I1. When V1 only on, the current flowing through R1, that is I1 dash, right? When V2, only V2 is on, here it should be algebraic sum. So I1 dash plus, here it is I1 double dash. At the same time, I2, that is I2 is also algebraic sum of, here it is I2 dash plus I2 double dash. At the same time, I3, that is I3 dash plus I3 double dash, right? Here polarities, here it should be algebraic sum. If both currents are same direction, here I1 dash is the clockwise direction and here I1 double dash is the anti-clockwise direction. So that's why generally here we are considering negative. Here it should be negative, right? Here also it is negative, but here in I3 it is positive only, right? So this is the superposition theorem statement. This is a superposition theorem statement. Okay. So we will do some problems. Yeah. Okay. So we will do some problems on superposition theorem. ప్రాబ్లం చేద్దామా లేకపోతే డైరెక్ట్ నెక్స్ట్ థీరంకి వెళ్ళిపోదామా? చాయిస్.
Problem.
Sir, I can't see the whiteboard, sir.
Who's that? What is the problem?
I can't see the whiteboard, sir.
Is that J4?
Yes, sir.
Why? What is happening? It is visible. Remaining people?
Sir, it is visible for us.
Visible.
Sir,
Sir.
should I rejoin, sir?
Oh, yes, do it. Rutvik, yeah. Tell me, Rutvik. Rule number J8.
Visible, sir.
Okay, okay, yeah. So here we will do one problem, that is uh, కొంచెం lengthy problem తీసుకుంటున్నా. So here it is voltage source, some 30 volts. Here it is current source, some 10 amps. Let us assume. Then here some here it is 3 ohms, here it is 5 ohms, then 4 ohms, 6 ohms, 8 ohms, then yeah. So here from the given circuit, the problem is from the given circuit, calculate the current flowing through current flowing through 5 ohms and 3 ohms resistor. From the given circuit, calculate the current flowing through 5 ohms and 3 ohms resistor by using SPT. What is SPT?
Superposition theorem.
Superposition.
Theorem.
Very good, excellent. Yeah, so this is the problem. Then, so according to superposition theorem, so here tell me, here how many sources are there? How many sources are there?
Yes.
What are those two sources?
Voltage source, current source.
10 amps.
What are those two sources?
Sir.
Voltage source, current source.
Voltage source and current. So 30 voltage, that is one voltage source. Then another one is that another one is 10 amps, that is another current source. So first consider at a time one source. So first ఏది consider చేసుకుందాం?
30 volts.
30 volts. So now again I am drawing the circuit. I am considering 30 voltage source. Here we don't have. So here it is current source. What we have to do in current source? It should be
Open circuit.
circuit. Right? Simple point, basic points. Here 30 volts. Then here resistors are, it is 4, it is 6, it is 8, then 3 ohms, then 7 ohms, then here it is 5 ohms, here it is 2 ohms. So here, so see, step by step. First, if you want to calculate the individual current in 5 ohms and 3 ohms, if you want to calculate the current individually, First, we have to know that the total current. What is the total current given by this 30 voltage source? This 30 voltage source, how much current is giving? That thing we have to calculate initially. So here total voltage is there 30 volts. Then according to that Ohm's law, what is that? What is the Ohm's law?
V
I
equals
is
to IR.
equal to I
V
is
by R.
equal to V by R. So if you want to calculate I, then we have to total voltage, we know that. Then we have to know that the total resistance. So that is first we have to calculate the R total, or we call it is R equivalent resistance. So how to calculate here equivalent resistance? When we have the voltage source here, then we have to start from the another end side. Here first element is 8 ohms. Here dead end element ikkada emundi 8 ohms, right? Next connected element to 3. Can you tell me what is the possible combination? 8 and 3.
Series.
8 ohms and 3 ohms. What is the combination? Yeah. Who's that? Who said that? Guys, who said that? Gajwada. 8 ohms and 3 ohms. What is the combination? Series or parallel? It is series combination. ఇంకేమైనా పాసిబిలిటీస్? ఓకే రుత్విక్, ఇంకేమైనా పాసిబిలిటీస్ ఉన్నాయా? జస్ట్ అబ్జర్వ్ ద సర్క్యూట్.
సార్ 8 ohms కన్సిడర్ చేయదు కదా సార్?
దట్స్ ద పాయింట్.
Yes, sir. Open, sir.
Here 8 ohms resistor, it is only one side is connected, another side it is open, it is not connected to the circuit. Then how can we consider that resistor? How can we consider that resistor? 8 ohms resistor is not considering in the circuit. It is a negligible one. You got my point? This 8 ohms resistor is only one side it is connected. Another side here it is open. It is not connected in the circuit. So this 8 ohms resistor is negligible. Next immediately connecting element is 3 ohms. Oh no? Then 3
Yes, sir.
ohms, 3 ohms, then 6 ohms and 7 ohms. What is the possible connection here?
Series.
Series.
ఏమేం సిరీస్ లో ఉన్నాయి? Which elements are in series?
And 6 ohms.
3, 7.
Step by step. ఇక్కడ చూడండి, total current. Here it is I total. Then this current is divided. Okay. Here some Ix current. Here it is some Iy current. Then this Ix current, see the path. Ix current ఇలా ఫ్లో అవుతుంది. 8 ohms లో ఫ్లో అవుతుందా?
No, sir.
Ix. Why current is not flowing in the 8 ohms resistor?
Because another terminal of 8 ohms is not connected.
Because of it is open. If it is open circuit, current will not flow. Then same current. Now tell me, what is the current flowing in 3 ohms resistor?
IX.
Ix. Same current now. So now in 6 ohms, 3 ohms and 7 ohms, what is the current flowing?
Same current.
Ix. Right? So that's why 6 ohms, 3 ohms, 7 ohms. What is the combination here?
Series.
So here initially it is 6 plus 3 plus 7, 16 ohms, right? That 16 ohms, see this 16 ohms. Now next connecting element 5, then it is parallel. That is 16 into 5 by 16 plus 5. How much it is? Calculate it. Calculate it.
3.80.
3.80 ohms. Then again, so here the resultant of 637, that is 16, then the resultant of 16 and 5 parallel, that is 3.80. The next level, that is 4 plus 3.80 plus 2. These are all series. So that is 7.80 and 9.80. This is the R equivalent. So the equivalent resistance, that is 9.80 ohms. 9.80 ohms. Copy it. Copy చేసుకోండి. కంప్లీట్ అయినప్పుడు చెప్పండి నాకు.
Yes, sir.
Dana?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, Gajwada. Completed?
Yes, sir.
B9. Rule number B9. Yeah. So then R equivalent is completed. Then we can calculate that next. Yeah, total current. That is I total. I total is equal to, what is that formula? Total voltage. Total voltage is how much here? 30 by R equivalent. Total resistance. How much it is? 9.80. Calculate 3 point
06.
3.06 amps. So here total current is 3.06. Here it is 3.06. Then if you want to calculate that IX current according to that current division principle, here which current is going to be dividing?
I total.
3.06 into another path equivalent resistance. What is the another path here? Here, see, in this path, it
5
is
ohms.
this path, it is Ix, and here Iy path is 5 ohms. So that is 3.06 into 5 divided by 5 plus
6
5
plus
plus
3.
6 plus
3 plus 7.
16.
3 plus 7. This complete path 6, 3 and 7 also is there. Calculate it, Ix value. Calculate it. Guys, make it fast.
0.72.
0.728.
0.7.
0.728. 728.
0.72. Yeah. Then Iy current. Then Iy current, that is equal to same current division principle. 3.06, another path resistor 16 by Yeah, 16 by 5 plus that is 16. How much it is?
2.33. 2.33.
2.33 amps. So now by using this 30 voltage source, we calculated current flowing through 5 ohms. Here Ix, that is nothing but current flowing through 3 ohms. Avuna? Then this Iy is nothing but current flowing through 5 ohms or I3 dash first because of we are considering one source, right? And here direction is also important, downwards. Then first step is done. Then second step, next what we have to do? Consider another source, right? So that is consider 10 amp source. So now the circuit is then this source. What we have to do? This source,
Short
voltage
circuit.
source ఏం చేయాలి ఇక్కడ?
Short
Short
circuit.
circuit.
Why? It is because of it is voltage source. It is short circuit. Then here the values are. Tell me the value here.
5 ohms.
Yeah, here it is 5 ohms. Here it is 3 ohms, I think. Then
Yes, sir.
4 ohms, 6 ohms, 8 ohms, then 2 ohms and 7 ohms. Is this correct value? Here current
Yes.
source is
Yes, sir.
10 amps. So here now when I am considering this current source, here initially the total current given by this source. What is the total current given by this source?
10 amps.
10 amps.
10 amps.
So there is no need to calculate the R equivalent because of we are calculating R equivalent for the purpose is to calculate the current. So here total current is given. So no need to calculate the R equivalent. Now yeah. So can you tell me what is the current flowing through 8 ohms resistor here? Current
10
value
amps.
10 amps. Then up to this point current is same. From that point current is dividing. Assume it is some IA. Here it is IB. Right? Okay, dash వద్దులేండి మళ్ళీ కన్ఫ్యూజన్ అవుతారు. IA IB. So now to calculate IA IB value, IA is equal to same current division principle. Here which current is going to be dividing?
10 amps.
10. Right? So now IA current, now tell me here, IA current is flowing through which element? ఏ ఎలిమెంట్ నుంచి IA current flow అవుతుంది చెప్పండి? 6
5 7.
6 5 7.
5 అంతేనా? 6 5 7 అంతేనా?
4 కూడా సార్ 4 2 కూడా
4 also, 2 also, 7 also. These are the elements. చూడండి ఇక్కడ IA current is coming like this, right? This is IA current. Then again this current is divided, but it is flowing the IA current only. And again here it is dividing. Again whatever the current, right? Again here some assume it is IA, IB, IB, IC. Here it is ID, right? Then again here whatever that, yeah. So again, this IC ID, again it is added together. Then here again, whatever the current flowing here, IA,
IA.
right? So here IA current is flowing through 6 ohms, 5 ohms, 4 ohms, and 7 ohms. So we have to calculate the equivalent resistance. So what is the equivalent resistance of all these elements? So start from the another end side nunchi. The current flowing through 4 ohms. What is the current flowing through 4 ohms? Here mention Jeshan Gada. What is the current?
IA.
IC.
No. Here, what is the current flowing? Here, just I am mentioning some.
IC.
IC, right?
IC.
Then again, what is the current flowing through 2 ohms?
IC.
Huh?
IC.
See,
IC.
IC only means 4 ohms and 2 ohms are series, right? So that is 4 plus
Series.
2. It is 6 ohms. Then the 6 ohms parallel with 5 ohms. That is 6 into 5 by 6 plus 5. Calculate it.
2.72.
2.72.
72.
Then again, the 2.72 is the resultant of 4 ohms, 2 ohms, and 5 ohms. Now all these three elements replaced with 2.72. Am I right? This 2.72
Yes, sir.
ohms is replaced with 4 ohms, 5 ohms, and 2 ohms. Now this 2.72, right, in series with 6 ohms and 7 ohms, right? So 2.72 plus 6 plus 7. How much it is?
15.72.
15.72.
15.72,
72.
right? So now in IA path, the resultant of all these 5 elements with different possible combination, that is 15.72, right? Now, can you tell me the possible combination? Can you tell me that IY path, sorry, IB path equivalent resistance? Can you tell me? IB path equivalent
Only
resistance.
3 ohms.
Only
Only
3
3.
ohms. So here, when I am writing the equivalent resistance, so here I am writing current IA is equal to here which current is going to be dividing 10 into another path. I am calculating current in this path. Another path equivalent resistance. What is it? Another path equivalent
3.
resistance
3.
3 by sum of both path. 3 plus 15.72. Calculate it.
1.60.
1.60 amps. Then next IB is equal to that is 10 into another path equivalent resistance 15.72 divided by 3 plus 15.72. How much it is?
8.39.
8.39 amps. Right. Then actually I don't want the IA current. Actually, I want ID current. ఇక్కడ 3 ohms లో find out చేశాం. It's done. Okay. But I want to calculate current in 5 ohms resistor. So for that purpose, what I am doing here, again, I am writing that. Here I am writing that. Yeah. So IC current. IC current is flowing through which element? 4 ohms, comma 2 ohms. And these two are series. So 4 plus 2, it is 6 ohms. Then ID current is flowing through which element? 5 ohms. Then equivalent resistance is 5 ohms only. Then to calculate that, to calculate that IC value, IC is equal to here. Which current is to calculate? అసలు IC అవసరం లేదు నాకు, ID డైరెక్ట్ కనుక్కుంటే అయిపోతుంది. To calculate ID value, right? Here which current is going to be dividing?
IA.
IA na 10 amps. I total IA na?
IA.
IA. That is IA into, right? Another path equivalent resistance. I am calculating current in this path. Another path means IC path. In IC path equivalent resistance is 6. That is 6 plus 5. That is IA is equal to how much? 1.60 into 6 by 6 plus 5. Calculate it.
0.72.
0.72 amps. This is the value of current flowing through 5 ohms resistor, right? So next ultimate
0.87.
0.
87.
Okay. Okay, happy? Right. So finally the current flowing through 5 ohms. Current flowing through 5 ohms resistor, that is equal to, first when I am considering the voltage source, అక్కడ ఏమనుకున్నా నేను? IX IY నా? IY కదా? IY here. When I am considering slow.
IY plus ID.
IY plus ID. Plus or minus? It is plus only because of both are same direction. So what is the IY value?
2.33.
2.33 plus ID value 0.87. 2.33 plus 0.87. How much it is? Then current in 3 ohms. That is
0.2, sir.
IX plus here we call it is IB, I think. IX much? IX is how much?
0.72.
Yeah, these are the values. Yes, so this is all about the Thevenin's theorem, right? So next, this is superposition theorem. Next one is Thevenin's theorem and Norton's theorem. రెండు కలిపి చెప్తాను, ఒకసారి జాగ్రత్త వినండి. Thevenin's theorem and Norton's theorem, both are same almost. The only difference is in Thevenin's theorem we are considering it is a voltage. In Norton's theorem we are considering it is a current. The only the difference is, right? Remaining is same. So here, suppose here it is the network. So here any two terminal linear bilateral network, here it is A point, phone ikkadi beta. ప్లాగ్ తీసేస్తే ఇక్కడికి ఫోన్ వద్దుకో. Yeah. So that is network. Yeah. So here any two-terminal linear bilateral network can be replaced with a single voltage source. Any two-terminal linear bilateral network can be replaced with a single voltage source in series with a. So here I am considering the network, whatever the elements are there, I am considering that those elements. Simple diagram. Here I am considering one voltage source. So here we have the AB, then this is the network. So this dot lines, this in this dot lines we have the network. Here just I am showing the some network, right? In that network, these are the elements are there. So it is network. So in that network, whatever the elements are there, here V1 is there. Here it is R1, R2, R3. So now, then this load resistor is as usual. So here any two terminal. So here these two diagrams are common for Thevenin's and Norton's. So any two terminal, that network should has the two terminal, any two terminal linear bilateral network can be replaced with a single voltage source. If it is Thevenin's theorem, if it is Thevenin's theorem, if it is Thevenin's theorem, right, replaced with a single voltage source in series with the single equivalent resistance, right? So between the AB terminals, whatever the resistor is there, it is as usual. This is RL. So here it is, yeah, this is VTH and here it is RTH. So the two terminal linear, this network should be linear network, this network should be bilateral network. It is completely replaced. So whatever the elements are there in that network, I am replacing all those elements with only two sources, two elements, that is VTH and RTH, right? So this is the Thevenin's theorem. In the Norton's theorem, what we are doing, in the Norton's theorem, same two terminal linear bilateral network replaced with a single current source, that is Norton's, in parallel with the single equivalent resistance, that is RN. And here it is same again. Between the AB terminals, whatever the load resistor is there, it is RL. This is Thevenin's and here this is Norton's. This is Norton's theorem. So here this VTH is the new term, RTH is also new term. So here IN and RN. So here the thing is how to calculate the VTH and how to calculate the RTH. So what is the procedure to calculate the VTH? What is the procedure to calculate the VTH? Calculate VTH. Same standard procedure here. Remove the load resistor. Remove the first point. Remove the load resistor. remove the load resistor and measure voltage across the removed terminals. Voltage across the removed terminals. మనం ల్యాబ్ కూడా చేశాం ఇది. So for that purpose what we have to do? So for the same circuit, remove the load resistor. So here I am drawing the circuit, remove the load resistor and remove the load resistor AB point. Vs, here it is R1, R2, R3, and here measure the voltage between the removed terminals. Remove the load resistor and measure the voltage across the removed terminals AB. So here VTH is equal to, simple procedure, VTH is equal to between AB, whatever the elements in this loop, whatever the elements are there, consider all those elements. So that is voltage across R2 plus voltage across R3. V is equal to, according to that Ohm's law standard, V is equal to what is that? I into R.
I.
Right? So same thing here I am writing. So that is whatever the current flowing through R2 into R2, then IR3 into R3. Now tell me what is the current, what is the IR2 value?
0.
0.
Why it is 0?
Open circuit.
Open.
Because of it is open circuit. Here the value of current is 0. So 0 into R2, how much? It is 0. 0 into R2.
0.
Very good, excellent. So it is completely 0. Then IR3 into R3. So here is.
Sir, what about the sign convention, sir? Sign convention for this R2 and R3.
R2 and R3?
Sign convention, sir. Like in
polarities?
Yes, sir.
See, here, see, actually, we are assuming we are starting from A point, right? Then current is flowing this direction. Then here it is plus, here it is minus, here it is plus, here it is minus. So in this loop, if you want to write down the equation, here it is minus VR2 minus VR3 actually. Avuna? According to Kirchhoff's voltage law, it is minus VR2 and minus VR3. Both VR2 and R3 both has the minus. So that's why if it is both has the minus, then I am considering the positive. If it is combination of plus, minus and plus ankondi, then we will take the exactly polarities. But here both has the negative polarity. That's why I am considering both positive. Minus common dishan ankondi. You got my point?
Yes, sir.
Yeah. So
Sir,
then
if voltage is between the resistance, then we need to take exact polarity, sir.
Voltage between the, yeah, if the some voltage source is there, then we have to take the exact polarities. Suppose here ఇక్కడ చూడండి, ఇక్కడ simple twist. Here some voltage is there. Here it is minus R3. Here plus minus some Vx, some value, right? Then, so now consider the polarities here. So now for that purpose, I am writing the equation VTH is equal to minus VR2, right? Then Vx plus or minus?
Minus.
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 Then minus voltage across R3. All three elements has the minus polarity. Then we can consider as plus because of all has the same polarities. Then we plus plus plus. You got my point?
Yes, sir.
For suppose here again I am writing another one. Vx plus or minus, guys.
Plus.
Plus, sir.
Plus, sir.
Plus or minus?
Plus, sir.
Why it is
Plus.
plus?
Because you have
Minus
negative
2.
to positive.
Negative to positive.
DS B సెక్షన్ అసలు ఎవరు రెస్పాన్సే లేదు. B సెక్షన్ DS
Yes, sir. Mine plus.
బండారు ఈస్ దేర్.
Yes, sir.
ఏమా అంత సైలెంట్ గా ఉంటే ఎట్లా? బి సెక్షన్ నుంచి ఎట్లా రావాలి అసలు సౌండ్? ఓకే, సో హియర్ ప్లస్ ఆ మైనస్ ఆ? ప్లస్ Vx minus VR3. Okay na? Then VR3 is equal to, here I'm taking exactly polarities. Here it is minus, here it is minus, here it is plus, here it is minus, here it is plus, here it is minus. Then VR3 is equal to, what is that VR3? I'm calculating for this circuit. That is IR3 into R3. So here in this loop, whatever the current flowing, we have to calculate. That is IR3, right? So in this loop equation, so here it is plus minus, then here it is plus minus. So here minus IR3 Vx, then minus, sorry, ఇక్కడ IR3 into R1. Here minus IR3 because of in the R1 resistor current is flowing IR3 into R1, then minus plus Vx, then minus IR3 into R3, then plus Vs is equal to 0. Here in this loop, I am assuming that in this loop, the current is IR3 current is flowing or some IX current, whatever the notation, it doesn't matter. Is this clear?
Yes, sir.
So from this equation, how to calculate the IR3? That is, yeah, minus IR3 common తీస్తే R1 plus R3, right?
Sir, we can't hear you.
What happened, ma? Okay. Okay, remaining thing we will discuss in the next class. Just 1 minute wait చేయండి నేను అటెండెన్స్ తీసుకుంటా. Attendance is the mandatory. 1 second please. Just 1 minute wait చేయండి. మీరు ఇప్పుడు లీవ్ అయిపోతే ఇంతసేపు ఉండి వేస్ట్. అటెండెన్స్ కౌంట్ అవ్వదు. One second. J3, J4, J5, J6, J7, J8, J9, K0, K1, K2, K3, K4, K5, K6, K7, K8, L0, L1, L2, L3, L4, L5, L6, L7, L8, L9, M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M0, M1, M2, M3, M4, M5, M6, N7, N8, N9, P0, P1, P2, P3, P4, P5, P6, P6, P7, P8, Q0 వరకు కదా లాస్ట్ డి సెక్షన్ సిఎస్సి డి సెక్షన్
Yes, sir.
Yes, sir.
యా
You not.
యా ఓకే P5 ప్రెజెంటా
Yes, sir.
Yes, sir.
P5 అంటే ఇద్దరు కలుపుతున్నారు 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 38 percent on 39 40 41 42 43 44 45 47 48 49 50 51 52 53 54 55 56 57 58 59 60 then 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 87 88 89 90 91 92 93 94 95 96 97 98 89 A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, B0, B1, B2, B3, B4, B5, B6, B7, B8, B9, C0. B9? Yeah, you can leave now.
Sir, sir.
No, Tali.
సార్ లాస్ట్ ఇయర్ పేపర్ పంపించండి.
Emma?
లాస్ట్ ఇయర్ పేపర్ పంపించండి సార్.
Previous year question papers.
Okay.
థ్యాంక్ యూ సార్.
మీరు గూగుల్లో గూగుల్లో వెతకండి అమ్మా, దొరికిపోతాయి. గూగుల్ తల్లిని అడగండి.
లేవు సార్ అందులో, నిన్న మొత్తం చూసినాం.
మీరు పంపించచ్చు కదా సార్.
ఎందులో సెర్చ్ చేసావమ్మా? రూల్ నెంబర్ 76.
గూగుల్లోనే సార్.
దొరకలేదా నీకు?
దొరకట్లేదు సార్.
ఏమని కొట్టావు?
క్వశ్చన్ పేపర్స్ అనే కొట్టినా సార్.
ఏం క్వశ్చన్ పేపర్స్ అని కొట్టినావు?
బీడబలి.
వెయిట్ చేయి. ఇప్పుడు
సార్ మీరు గ్రూప్ లో పెట్టండి సార్.
గూగుల్ స్క్రీన్ షాట్ కనిపిస్తుంది ఇప్పుడు నీకు? నా స్క్రీన్ కనిపిస్తుందా నీకు?
Yes, sir.
ఓకే. JNTUH ఇక్కడ వచ్చింది చూడండి. JNTUH క్వశ్చన్ పేపర్స్ R1811. ఎంటర్. డైరెక్ట్ దాని మీద క్లిక్ చేయండి. దెన్ కనిపించినాయి. బేసిక్ ఎలక్ట్రికల్ ఇంజనీరింగ్ 2018, బేసిక్ ఎలక్ట్రికల్ ఇంజనీరింగ్ May 2019, basic electrical engineering December 2019 John. క్లిక్ చేయండి. డౌన్లోడ్ ఫైల్. ఏమొచ్చింది? కనిపించింది ఏమన్నా? డౌన్లోడ్ ఇట్, సేవ్ ఇట్. వచ్చిందా? ఎంత టైం పట్టిందమ్మా ఇప్పుడు? లిఖిత 76.
సార్ నిన్న రాలే సార్. నిజంగా చూసిన సార్.
65. రూల్ నెంబర్ 65.
సార్
ఎంత టైం పట్టింది ఇప్పుడు?
నాకేం తెలుసు సార్ గూగుల్లో ఉంటాయని, అందుకే మిమ్మల్ని అడిగాను నేను.
గూగుల్ తల్లిని అడగండి. ఏదైనా గూగుల్ తల్లి దగ్గర ఉండదు అని ఏమి ఉండదు. అయితే మీరు ప్రాపర్గా సెర్చ్ చేయండి. ఇప్పుడు నువ్వు సెర్చ్ చేసుకుంటావా నన్ను పంపాలా నేను?
తీసింది కదా సార్, పంపండి.
అదే కదా సార్.
ఇంత బద్ధకం అసలు. బద్ధకంకి బ్రాండ్ అంబాసిడర్ ఉన్నారు మీరు. ప్రిపరేషన్ స్టార్ట్ చేశారా?
ఎస్ సార్.
స్టార్ట్ చేశారా ప్రిపరేషన్?
చేసినాం
సార్.
చదవండి కొంచెం స్టార్ట్ చేయండి. క్వశ్చన్ పేపర్ టఫ్గానే ఉండే ఛాన్సెస్ ఉంటుంది.